Here we go. Are we ready? Hey, if Soil went to an online dating website, what would its profile say? It's a setup for some horrible joke, some teacher joke, right? But what is a soil profile? All right. Soils have horizons. Horizons are just layers, and the soil profile is all those layers top to bottom taken as a chunk. That is a good looking soil profile. Oh, yeah. No, not really. All right. So we're going to talk about soil profiles. All right. Soil profiles, your book, the textbook you haven't seen this year, that one, says soil profiles have 3 horizons, A, B, and C. And if you took a glance at that last picture of this reference, soil profiles have a whopping 3 horizons. No, 3 horizons, A, B, and C. Oh, and then there's O, E, and R. Okay. We're going to talk about 3 horizons, A, B, and C horizon, what they are, and then we're going to add the other stuff in and see what it is and how it fits into that same picture. So the first horizon is the easy one. It's the A horizon. Just means the horizontal layer is layer A. It's the top layer. It's topsoil, right? It's the uppermost part with all the organic matter. It's got loose leaves, decomposing plants, insects, fungi, microorganisms. It's the topsoil. It's good stuff. All right. What's the B horizon then? The B horizon is below the A horizon, subsoil, right? Fine clay particles that wash out of the A build up in the B horizon. You've still got roots in the B horizon. You've got all sorts of burrowing animals. But sometimes every now and then, if the B horizon clogs up, the B horizon, if you clog it up with all those clay particles, you can get hard pan, which is not easily penetrated by water. Okay. It's the lower limit. The bottom of B is where most roots, most plants and animals stop. And then you've got C horizon. C horizon doesn't really have a definition except that it's between B and the parent material, the bedrock. So the C horizon is partially weathered parent material. And that's it. It's just the layer in between B and rock, bedrock. All right, so let's scroll down. A horizon. This is not the best A horizon picture, but it shows you've got some grasses and you've got a lot of, it's loose, it's not compact usually, it's good growth, it's got organic matter, all sorts of stuff's going on. That's the A horizon. The B horizon starts down here. If you see, follow the yellow outline. The B horizon, less organic material, more clay that's washed out of the A horizon, and then down below you've got a C horizon where you have very few plants or animals, and this is basically just before you cross over to bedrock. Whatever, those all vary in different depths depending on where you're at. So those are the basic 3. What are the rest? O, E, and R. O is organic. Organic, but not organic plants, plant roots, animals, insects, but organic that's not decaying. If you've got a huge giant leaf pile, that's not soil, but it's organic material. It's trying to become soil. Like if you dig down and the pile gets wetter and wetter and wetter, and the leaves start to get smaller and smaller and smaller, and then all of a sudden, where does that pile stop and the next layer start? That's what O is. O is at least 20% organic matter by mass. Okay, so huge piles of, this says you can get them in a couple different ways, but you've got stuff that's decomposing slowly. And it's, or not decomposing at all. It's just stopped. That's O. All right. And then E. E is not always present. First of all, E does not have to exist. But the way we said that the clay leaches out of A and builds up in B, sometimes if you get that to an extreme level, you add an E horizon. has lower clay content than the B horizon and lower than the A horizon, if the A is present, right? So the E here stands for alluviation, right? It's a significant loss of minerals, okay? So E is a significant mineral loss, and it's not always present. It's really usually fairly narrow band. It's lighter in color. Those are the other things it's talking about. R, rock. It's bedrock. So O, A, E, B, C, R. Even though it's just ABC, right? It's super simple. It's ABC. And then we throw just as many oddballs in there to remember. So the other question, do you remember chlorped? The what? Chlorped. Last time we barely mentioned it. Something about, I don't know, climate, organic, relief, parent material, and time. You know, the things that determine what a soil is going to be. Chlorped, you know, that stuff. No, oh, it's all right. Here we go. We're going to look at some good soil profiles. Actually, I'm going to back up, get out of that. There we go. And this is a really good website. You're going to see part of this in your assignment. It's got a lot. Let's just go there. It's got a lot. State soils. So you can't choose Missouri. I'm doing Missouri as a demo. You may not choose Missouri. Choose another state. Click on it in this box. Bring up a profile and read. Answer some questions about it. All right. The state soil of Missouri. No, Minfro. Minfro is a Missouri soil. What is Minfro soil? Well, it's clay-like. You probably can't read that. Here we go. Nope, not minus. There we go. Now let's go one more, two more. Here we go. Clay-rich forest soils. You've got all sorts of washdown, seeping rainwater. It accumulates. Where? Where is it at? Ooh. It says Mississippi River. That says Missouri River. And then there's that ridge there that separates southeast Missouri and the flat plains that go out to the Delta, all the way down to Louisiana, and the Ozarks here. And you can see that. This red is Minfro soil. So even though it doesn't cover most of the state, it's still a defining state of the soil, defining soil of the state. Right, there we go. Uses, limitations, how you can get some of it. Look, there's the chlorped right there. So I like this map quite a bit. This in the gray, there's Cape Girardeau. There's Poplar Bluff. There's the Bluff Hills. There's the White Hills, White River. You can see the Missouri River come in. You can see the Missouri River go across, the Mississippi River come down, and how you've got these soil types, and then you've got an Ozark Plateau, and then you've got lowlands. The soil, this is not elevation, but you can see those changes just by looking at the dirt in any given spot. And then you read this, and it tells you what that dirt stuff is. It's got a nice glossary. So you're going to answer some questions about this from a different state, and then we'll see how it goes. All right. We're going to look at a couple other broad categories. Last little thing for today. Broad categories of soil types. We've talked about different soil types. We're going to look at a couple more. Petalfer, Petacol, and Ladderite. What? Go with me here. Petalfers are temperate areas, meaning not super cold, definitely not tropical. They're temperate. They change. They've got good seasons, right? More than 63 centimeters per rain of year. It's the eastern U.S. It's the forested areas, right? The B horizon contains lots of iron oxide, lots of aluminum oxide. It makes this brown-red soil. Lots of the eastern U.S. is a petalfer. Pedicle, it's the drier western U.S. It's more prairie, it's grasses and brush soil, right? Less clay, right? The chemical weathering is slower in these drier areas, so it's got lots of calcite built up in it. It's light gray, brown. Big, again, these are big categories. Got one more. Ladderite. And I want to show you. Go away. Ladderite. Ladderite is a hot, wet, comes from hot, wet tropical regions. All right. Chemical weathering is very intense because they get so much rain. When I say tropical, like monsoon season tropical, okay? And when you have that much water hitting, the chemical weathering is very intense. It happens a lot. They make deeper soils, like each of the layers goes a little deeper because there's so much water filtering through. It removes a lot of the calcite. It removes a lot of the silica, but that leaves iron oxide, aluminum oxide. So you've got this red, brown, orange, or red-orange color. All right. And then this stuff, when it dries, it hardens, and it's almost waterproof. It has been harvested as brick for centuries. Okay? Here's the odd thing. So this is Ladderite, and you can see this in formation. And I want to come down and I want to show you that. You can get, as long as it's wet, you cut it, and then you let it dry in the sun, and you've got brick out of this. When moist, they can be easily cut with a spade into a regular-sized block. It's mined while it's below the water table, soft and wet. Upon exposure to air, it gradually hardens. Moisture between the fine clay evaporates, right? Rigid ladder structures become resistant to atmospheric conditions, aka almost waterproof, right? So, Indian subcontinent, all right? We've got, here we go. Angkor Wat, present-day Cambodia. Here we go. 1100. It's a World Heritage Site. There's a picture of it. We're going to get you a better picture of it. There's a couple. But we want to see the brick of it, right? We want to see the structure of it. As we from the side. These bricks are cut and mined and built not quite 1,000 years ago, and it's still chilling, doing its thing. Like, this is in Cambodia, so when we say very wet, very rainy, very hot and tropical, it's absolutely that way. All right. Now, there's a problem with this laterite soil that's not obvious, because with this soil, you often think of tropical rainforest, and you see these trees growing so fast, and there's dense vegetation. It doesn't have to be a rainforest. It's just dense vegetation. Everything's growing. But the soil below it is really poor. You're like, how in the world can all these things grow in so poor soil? It's not that this, here, plant dies, animal dies. In that condition, the hot, wet, humid, tropical condition, it's going to decay really fast. And then the plants nearby are going to soak up those minerals. The reason is the minerals don't stay in the soil because the water keeps washing them down and out, or the other plants absorb them. So if you cut this down, if you deforest this and you try and grow crop on it, you can grow for a couple years, but the soil doesn't have enough mineral in the soil. The water washes the mineral down, deeper layers, or the mineral gets absorbed by the other plants. And so once you cut the forest down, you've just got the soil there. There's nothing else adding new mineral to it. It's actually really poor soil. And now that you've deforested it, you can't. It's a pain to get restarted and regrown the dense vegetation. And so you've ruined that whole area. Nothing grows on it now. Okay. Soil erosion. Soil erosion is a big thing. Dust Bowl, you've heard of that, right? They've looked at old ways the soil erodes. The number of kilograms the rivers used to carry, how many they carry now, it's more, it's increasing. Soil erosion is a big thing. The sediment that builds up in rivers, we've got to dredge the river, and the sediment builds up on the backsides of dams and different things. You've got all of these sediments. First of all, soil erosion is natural. Soil erodes. goes out, sediment forms, sediment compacts, sediment makes new rock, and then you've got rock cycle. Rocks uplift, rocks dive under each other, they subduct, they do all their rock cycle. New rock, old rocks, rocks build layers, sediment. So sediment builds up in layers. That's sedimentary rock. It will eventually become. That's natural. The issue is that we are stripping and eroding the soil faster because of things humans do than the soil gets built back up because of things nature does. So there's an imbalance. So plant your crop row, less no-till soil, no-till farming, tree and wind breaks, watch your slopes, watch your erosion, construction sites, build those barriers. They are important. Don't clog up the drains, So watch the erosion. Guys, it's spring break time. We're talking about dirt. Go out, play in the dirt, play outside, enjoy your spring break, and I'll see you when we get back.